It's very, very powerful for the reader because it does make you believe that you're in a kind of real flesh and blood body. And again, it's this intersection of the physics of time travel and the philosophy of time travel with the biology of a real person.
The Time Machine was an enormous success, offering people a glimpse of what it would be like to make the ultimate escape. The escape from time, even from death.
Questions of time are obviously incredibly important to us all in our everyday life, and questions of mortality. And mortality is obviously the kind of the sort of the horizon of time for each of us individually. And I think that anything that allows us to sort of have a sense of sort of escaping that kind of inevitable end of our own time is quite appealing.
But now, after years of being treated as science fiction, it seems that time travel could be science fact. The thing is, the laws of physics don't have any problems with time running backwards. So we physicists believe that it just might be possible to build a time machine. The only obstacle we face is one of engineering. That's because the theoretical blueprint for our time machine already exists. A machine that's secret lies deep within our microscopic universe. At the tiniest subatomic level, the fabric of space and time becomes so unstable that it starts to behave like a foam, its surface alive with tiny bubbles momentarily popping in and out of existence. We call this quantum state the space-time foam. It's thought that contained within this foam are objects called wormholes, tiny passageways between 2 points in space and time. The secret to building a time machine is to stabilize the space-time foam long enough to make one of these wormholes permanent. And the way we do that is by subjecting it to enormous amounts of energy. I'm standing 100 meters above what will be, when it's finished, the world's most powerful particle accelerator. This machine, scientists hope, will help to unlock some of the secrets of the mysterious world of subatomic particles, the building blocks of our universe. This tunnel is 27 kilometers in circumference, and it houses the accelerator. Inside this chamber, 2 beams of subatomic particles will be traveling in opposite directions, boosted to near the speed of light. As the protons within the beams collide, they shatter into even smaller particles, releasing bursts of energy roughly 500,000 times greater than those inside a nuclear explosion. But even the most powerful accelerator on this planet can't produce enough energy to stabilize a space-time foam. To do that, our particles would have to be moving even faster, and that would require an accelerator of truly enormous proportions. So big, in fact, we would need to build it in space. Now, we know that if you smash particles together at extremely high velocities, eventually you create something called a quark-gluon plasma. An extremely hot, high-energy cauldron of matter with a temperature exceeding 10 trillion degrees. By adding even more energy, blasting the plasma with lasers, we can finally stabilize space-time foam, long enough to pluck out a minuscule wormhole. The next task is to enlarge it, and even that is scientifically possible. In 1948, a Dutch physicist named Hendrik Casimir introduced us to a mysterious new force called negative energy, complete with anti-gravitational properties. So far, we can only create minute quantities of this in the laboratory. But one day, if we can create enough negative energy, we might be able to increase the size of a wormhole. And this is how we think our wormhole would look. Each end a sphere, held in place by an electric field, invisibly connecting 2 points in space and time. By subjecting one end of the wormhole to a huge gravitational field, we could bring its clock almost to a stop. This turns our wormhole into a time machine. Both ends existing in the same place, but at different times. Our ability to build such a machine is still some way off. But just knowing that time travel is possible is enough to turn yet another of our assumptions on its head. Time isn't necessarily one way. It can move back as well as forwards. Within the fabric of our universe lie the means to a temporal freedom that until now has only existed within our imagination. So what would we make of the chance to cruise through space and time? To visit the past, perhaps even to change it. I have here 2 tickets to take you back in time.
Would I take a journey back in time? Most definitely.
You could change an incident in your past. Would you go back and do it?
I think the Titanic. I'd probably go back to my teen years.
What about telling the captain, by the way, there's an iceberg coming? Would you do that and interfere with history?
I don't know if I'd interfere with history.
I think that if you actually change something for the better in the moment, it would actually expand something for the positive in the future.
I wouldn't alter, because then there you start playing God in there, and that's not right, so...
These were like a one-way ticket, and you couldn't come back to the present. Would you still want to take that trip?
I wouldn't want to go back and not be able to come back to what I know and my children.
I don't believe I'd take the ticket.
I think the present's pretty good.
Living with the past fixed and the future unknown makes us feel secure in time. Change that, and you change everything. So far, we've seen how time, which appears to be so regular, can in fact be quite flexible. We've seen how time can behave in such unpredictable ways. And as we understand more about time, it's even becoming possible to solve perhaps the greatest mystery of them all: whether time is eternal.